Welcome to Sustainably Speaking. I'm Joshua Baca. Did you know that plastic materials are going to help usher in the next generation of mobility and transportation? Surprising as it may seem, the same materials we use to package food, transport clean water, and even insulate our homes will play a critical role in helping America transition to a low-carbon future, especially when it comes to transportation and mobility. Each year, we've seen automakers add more EVs to their lineup. From well-established industry leaders like Ford to new names like Lordstown and Rivian, we've witnessed revolutionary innovations and adaptations that have transformed cars into high-tech and low-impact mobility masterpieces. We have two transportation visionaries on the podcast today who will help us understand what it takes to build a better, more sustainable vehicle and infrastructure future. Dr. Debra Mielewski is a technical fellow of sustainability at Ford, and Paul Snyder is the chairman of the Transportation Design Department at the College for Creative Studies. Both have deep expertise and insight into what it takes to create meaningful automotive advances seen and unseen in both design and creation and even the future of electric vehicles. So with that, why don't we get this conversation started? Paul, Dr. Debbie, thank you so much for being here with us today. Why don't we just dive in? Why don't you tell us a little bit about yourself, and maybe we start with you, Dr. Debbie. Tell us a little bit about your role at Ford and, what you do every day when you wake up to think about automotive and sustainability.
Well, first of all, thanks a lot for inviting me today. My name's Debra Mielewski. I am the newly minted Technical Fellow of Sustainability at Ford, which gives me the impression that sustainability is really of rising importance within the company, something I'm really super proud of. When I get up in the morning, I start thinking about what Ford Motor Company can do to lower its impact on the planet, how we can achieve carbon neutrality, how we can do less damage as far as landfilling of materials. And so it's a very, very broad scope. My first 20 years I spent in materials development, so I know a lot about materials, but I am really trying hard to catch up on all other aspects of sustainability.
And Paul, how about you? Tell us what you do for a living and why you're part of this conversation today.
Thanks, Joshua. My name is Paul Snyder, and I'm the chairperson of the Transportation Design Department at the College for Creative Studies. It's a 4-year program. Many of our kids come right out of high school, and they're very aware of the environmental damage that's been done and the urgency that sustainability brings to the table when preventing more of that to happen. So I'm very glad that they're aware of these issues, but they don't have the technical skills yet to really address them in any meaningful way. So that's part of our goal. Obviously, they do need to, learn all the traditional skills and all the new digital skills that are required to participate in the industrial design studios of today and tomorrow. But, the fact that they're coming to us with this knowledge is a good thing.
So let's pick up there. Great intro from both Dr. Debbie and from Paul. And I want to talk a little bit about what sustainability means. What does sustainability mean in the context of the automotive industry? Dr. Debbie, why don't you kind of kick us off and give us your thoughts there?
Yeah, so sustainability is really reducing the impact on the planet in all phases of the vehicle production. And so we have to worry about our emissions at the plants, the materials that are manufactured for us by tier 2s and tier 3s, the amount of energy that is used to make parts at the tier 1s, and the vehicle itself, the product itself, and how sustainable it is for the 10, 15 years that it's on the road. So fuel economy, durability, the last thing you want to do is keep replacing parts because those parts take energy and materials to manufacture. And so there are so many ways, and at an end of life. So I really do want to start working on end of life. We've talked about it in the automotive industry for 30 years, but we still crush and put the plastic materials into landfill. So at end of life, what's the most responsible thing to do with those plastics? Can you use them in another application? Can you close the loop and put them back into new vehicles? So sustainability is addressing all of those aspects, trying to keep the air clean, the water clean, use less, and make the most out of the resources that we do use.
So kind of reading through your words a little bit, if we're using less material and having to switch out parts less often, that should be a money saver for consumers. Is that correct over the long term?
Well, one would certainly hope so, and especially if at end of life, the vehicle still has value, right? Right now, most of the 500 to 700 pounds of plastic is shredded and put into landfill. Just imagine if that material could be brought back into a company like Ford and used on another new vehicle. This is my hope for the future, is that we start closing that loop, and it really should. Every sustainable material I've put onto vehicles, coffee chaff filled plastics, wheat straw filled plastics, tree fiber filled plastics, have all reduced cost and been better for the environment, and they're lighter weight. And so I have a lot of hope that technology is going to take us where we need to go.
That's awesome. I happen to own an electric vehicle, and when I got the car, I was so surprised. You don't really appreciate the depth of the design and the materials that go into it to making it not just a beautiful car, but an efficient car. So I think you could have sustainability and beauty at the same time from what I've seen. So Paul, why don't you hop in here? Give us a little bit about, when you talk about sustainability with your students, what do they think that means, and what does that mean to you?
Oh, that's a pretty good segue, actually, Joshua. The beauty of a car or the experience of a car, addressing all the different consumers' tastes and desires, personalization, all those things lead up to the different kinds of materials that we need to use. But sustainability within the classrooms is a very broad topic, as Dr. Debbie mentioned. In some of our mobility-focused classes, we have students that will envision dropping 20 or 30 autonomous vehicles into a disinvested community in order to get the kids to school, which is a great idea, but sustainability also has to be considered on a business level too. So how is that sustainable? Like, how will that continue to pay for itself? And then in our materials and manufacturing classes and other technical classes like packaging and so on, we do get into some of the new biodiverse plastics and polymers that are coming out. So our students are very much aware of them.
That's awesome. And I kind of want to dive headfirst into that. Both of you guys said, and we talked about in the intro, the role that plastics play in the design of modern vehicles, lightweighting, emission. Can you maybe dive in here and talk a little bit about that? For the listener out there, I think they might think of a piece of plastic being their bottle. I don't think they necessarily think of it being, one of the main pieces of material in their car. So can you guys elaborate on how that works and why that's important to your sustainability goals?
I think I can maybe comment first. So plastics have a bad reputation right now, right? Everybody thinks that plastics are evil, and we do have issues and problems to solve. But for the automotive space, in a durable product, plastics have provided us with amazing lightweighting over the years, incredible safety improvements. There is no way we could survive with airbags deploying through metal structures. So plastics in their ability to deform at low temperatures and not create an issue for the people that are in the vehicle, we can't go backwards here. Fuel economy would just completely be ruined if we started replacing plastic with high density metals. And so what we need to do is we need to figure out the issue of end of life and sort of make sure that we're using the plastics appropriately and as efficiently as we possibly can. And I think that's where we kind of drop the ball, because when the car comes back to a crusher or a shredder facility, Ford doesn't have any responsibility for that vehicle, General Motors, the other automakers. And if there's value in it, then we will want to take that vehicle back. So when you were talking about mobility and dropping car companies owning the vehicles and dropping mobility into certain sections, we would actually own those, and at end of life, we'd want to extract value. So
you touched on something there that I want to pick up on, and you used the word safety. Our average listener may not think that they might be safe in a car that includes plastic. Can you explain that for us a little bit?
So every single airbag deploys through a plastic substrate. And so they're hidden behind, and it has to, at minus 40 C, be ductile and allow that bag to deploy through it. Your seatbelts are nylon plastic. Plastics are everywhere in the interior, and there's just no way that you could generate the low weight and the safety without the use of them.
Safety and sustainability. There we go. How about you, Paul? What are your thoughts on the role plastics play in designing vehicles today?
Well, I think, just sticking with the safety conversation, if you take a much longer vision to the extent that legislation is eventually in place where autonomous vehicles, for example, could operate in an isolated, let's say, geo-gated zone of a city or something like that. The assumption is, in this case that I'm mentioning anyway, is that the vehicles operating within that system are all going to be algorithmic controlled, and there will be no drivers. And if there are no drivers, the assumption is there'll be far, far fewer accidents. And so a lot of the weight can be removed from a vehicle if you take the driver out of the equation, because drivers are notoriously, really good at getting in accidents. You see it every day, hundreds of thousands of people per year globally. So that's one way we could do it. And the really cool thing that I'm seeing in regards to plastics on the exterior of a car is the different ways plastics can disguise or hide or become even interesting features around the sensors that are needed for these autonomous vehicles. There's a vehicle that just came out from NIO, I think just debuted. They're going to build a factory somewhere north of Europe. And all the sensors are covered with these beautifully organic surfaces that are made out of, I think they're polycarbonates from Covestro. And so as autonomous and these different kinds of safety systems become more and more ubiquitous, which they are really quickly, plastics will be used in order to protect the sensors as well as disguise them perhaps, or even make a feature out of them if that's something that is deemed desirable. So there's a lot going on if you think, just a little further forward.
Yeah, so this whole idea of autonomous vehicles, they will increase the use of plastics, because why would you want to use steel or aluminum with their high density, 3 for aluminum, when plastics is around 1 gram per cc? So the opportunity to get higher range from batteries, or if you use fuel, better fuel economy with plastic.
Mm-hmm. Yeah, weight equals fuel economy in many ways, or even energy efficiency, whether it's EV or fuel.
But let's talk a little bit about emissions. You guys are both talking about, the efficiency here of a vehicle with plastic materials. Can you just walk us through maybe the transformation and the evolution of cars and emissions over the last, several decades? I know this has always been a big public policy issue, but it seems like modern design and improvements in technology and a whole host of other things have kind of really taken this issue head on. And you guys are now kind of leading in this area. Is that a pretty fair statement to make, Dr. Debbie?
Yeah, it's been quite the journey. I remember the initial Obama days where we were going to get to 55, 58 miles per gallon, right, by this time probably. And there's been this whole shift from internal combustion toward the battery space. We want to make sure that the batteries are the right option. And as we make that shift, that the customer is pleased and not frustrated with that battery, right? So you got to make sure there's adequate range. You got to make sure that there's places to charge. You got to make sure if they turn on their air conditioning or if it's cold outside that they don't run out of range. So there's a lot still to be challenging, and there's still going to be a lot of internal combustion on the road over the next 10 or 15 years. And so we still have to improve fuel economy there and worry about emissions there. It's a complex time to be in automotive for sure.
Super exciting, though. Really exciting times. It's revolutionary what's happening right now. And it did take a really long time for it to happen, but it is understandable. With the range anxiety and people wondering where they would charge their vehicles in any, reasonable time frame if they were to take a road trip. But I do think that the awareness of the environmental damage that emissions has been causing have made it a much more popular option. I know my 14-year-old wants me to get a Tesla, but the fact is they're kind of premium vehicles still. All electric vehicles, they're not price competitive just yet. They're coming down, which is great. It's taking longer than I think we all want, or certainly in my case, longer than I would want. But it is coming, and it's enabling a lot of really cool opportunities.
And it'll be an interesting study in economics, right? Because people want to pay the least as possible when they buy something. But if you look at an electric vehicle, the costs over time are lower. So you get your gains in economy by holding onto that vehicle and paying less to run it on a day-by-day basis and less for maintenance. Electric vehicle has hardly any maintenance associated, no oil change, right? This regular maintenance that we do on IC engines. Will people buy into the idea of the long-term gain and the environmental one? Like there's a whole group of growing young people that are just interested in making sure that what they do doesn't damage the environment.
So to that point, you guys both raise important topics about the future of transportation with electric vehicles. We obviously see them with several models out in the marketplace. Why have electric vehicles become so popular?
Well, like I said, young people certainly are very much aware of it. And I think the older generations are starting to warm up to the idea that, yeah, climate change is a real thing. You're not going to get many scientists disagreeing with that anymore. So there is a certain urgency there. And then I think also with the fact that we have some really interesting new brands marketing them, it's become kind of sexy and desirable, and also a sort of badge of honor to be driving around in something that's not furthering the damage to the environment. Certainly that's the case. And as I said, it's kind of a premium thing, so it's not quite accessible yet. But, with players like the traditional OEMs in the United States starting to enter the market, I think that the competition will drive prices down pretty quickly.
Yeah, and I can't add much to that. I totally agree with everything you said. I want to put a exclamation point around the fact that we have about 10 interns that come into our lab every single summer to work on sustainable materials. So they will add like lobster shells to plastic materials, make composites out of things that are waste products. They are so excited about this transition. I don't think, just like I said, we're not going back on plastics. I don't think we're going to go back on powertrains as well. They want to see progress.
Yeah, there's something happening with fungi, cilia, mushroom-based materials as well that my students have discovered.
Mycelium, yes.
Yeah, mycelium.
Yeah. So we look at that as well. I mean, there's so many opportunities. We've ignored all of the waste products of agriculture for, as long as we've been building cars. And so the opportunities are all there. This is all stuff that's burned. You take almond shells and you burn them, and they make a perfectly good substitution for talc materials that we mine. And so every time we mine the earth, we destroy a section of it. Why the heck aren't we using the almond shells? And that's pretty much what our group is centered around, is closing the loop, taking all the waste, what people call waste, and saying, no, these are actually premium to what we currently use. And we're also improving the planet.
So, Dr. Debbie, Ford has been in the news recently. The president was seen driving electric vehicles and the F-150. That's a pretty cool, evolution here, both, in regards to the generational transition of, maybe an older generation used to a big pickup truck filling up with a tank of gas, and now it's an electric pickup truck. Can you tell us about that F-150? Because I know as a consumer who follows the auto industry, that was some exciting stuff and seeing the development of that.
Yeah, and I saw the video of Joe Biden taking off in that car, and it was like uncontrolled power. And if you've driven electric vehicles, they can be super fun to drive. And that's really our objective at Ford, is to make sure that these vehicles are exciting to look at, right? We don't want to just have an electric vehicle and have it look mundane and not be fun to drive. We want to take all of that expertise from 100-year-old plus company and make sure that these vehicles are as fun as our other vehicles for people to own and to drive, and as durable. So yeah, it was really, really a big moment to see Joe Biden take off in that thing. And I know what that feels like. There's nothing like pressing on the accelerator and just having it take off like immediately. So the torque is amazing on electric. It's
the
fun.
torque monsters. They are a lot of fun to drive. Tesla's had that ludicrous mode for a while in the Model S, and I haven't tried that one, but I understand it's pretty neck-snapping in terms of acceleration.
How about we start talking about the future? And you guys both mentioned a little bit about autonomous vehicles. How far away are we from a world where we get in a car and it drives me to work and I can sit down and take my phone call or answer my text or maybe drink my coffee. Are we headed towards that, or is that still a long ways away?
I'm letting Paul field this one because I'm just a lab geek.
Well, it's a slow journey. As you said, Dr. Debbie, we're still selling cars with IC engines, right? And so those cars will be on the road potentially for 200,000 miles or more. And that lifespan of mileage will play out over something like 15 years or so, in some cases more, in some cases less. So the full advantages of autonomy, in my view, can't really be leveraged unless, at least in the short term, unless we have zones where autonomous vehicles can operate safely without drivers. If you can imagine autonomous vehicles having to accommodate drivers on the road, and the efficiencies that autonomy could provide are limited. In other words, the weight will have to continue to be quite heavy because you're going to need crash structures in case a driver slams into you. But the technologies are certainly there. You have companies like Zoox, which is just acquired by Amazon not very long ago. Neuro is doing these little delivery bots. Yeah, and there's a multitude of others. So it's definitely coming. On some level, I think, everybody is suggesting that transportation design programs should change their name to mobility, and some institutions, universities, and colleges have. I'm thinking that probably robot design is closer to the mark than just mobility, because what we do is really, when you incorporate all the different kinds of sensing and intelligent machines, we're designing the first robots that humankind will ever have a mass impact with, or initially anyway. And so that's all very, very exciting, but it will take time. It'll be incremental. Legislation is not there yet. They're letting the OEM sort of take the lead. So it's going to be very, very messy. I do think that the United States has to champion this effort a little bit more concertedly, because, as President Biden has said, China's going to eat our lunch with EVs as well as with autonomy. They have such a system wherein they can just say, okay, so let it be said, so let it be done. We are now going to be autonomous in Shanghai, and it'll just happen. Where, we have a liberal democracy and people vote. So it's going to take a little bit more time for people to let go of the steering wheel. And many people don't ever want to do that. I certainly don't, but I do think that there's a time and place where the urgency of climate change creates pressures. So in the very same way that people still have horses and very much enjoy riding horses, I think that there's going to be racetracks, and you'll be able to race an electric vehicle or race an IC vehicle and have a great time, and then get into an autonomous shuttle and go back home thinking you had a great time, but you're still being environmentally conscious about the whole endeavor.
Yeah, and I'll just add that this is a huge, huge undertaking, having a vehicle make all of these decisions with AI and machine learning, double computers on board so that you don't have any failure states. So it is going to be a slower rollout, and people tend to get excited by media portrayals of this happening in a short time span, and then we get disappointed when it doesn't. And so I think Paul is totally right. We're going to see it where it's appropriate, where it's safe, slowly roll out and become more mainstream over time. We need infrastructure, we need support that isn't there right now. So you'll see it on a small scale and it'll mature.
The other thing that's happening is with autonomous shared vehicles, sure, there'll be autonomous luxury vehicles where you don't have to drive. It's going to be its own chauffeur, and those will be very wonderful. But autonomous shared vehicles are a huge threat to the business models that our industry has been enjoying for the last 100 years. If you don't have to buy a car, then how does the industry make money? Well, they have to start selling miles. And as Debra was saying, this could be a really good thing for the environment, because if the vehicles are intelligent enough to know when their lifespan has transpired, then the vehicles just drive themselves back to the recycle factory. And every part in the vehicle, whether it be plastic or steel, has its own sort of RFID code, and it's talking to the recycling factory, telling the factory that, okay, I'm plastic, I'm this kind of plastic, you can use me this way, goes right into that bin. Which is great for efficiencies, but the fact is you're not selling as many vehicles. So that's scary for the industry. It's good for the planet, but scary for the industry.
What about, if we could pick up there, you guys both touched on public policy, the need for infrastructure to deploy more electric vehicles, the role plastic materials will play in lightweighting those vehicles to extend the range. What role does public policy play in this?
Yeah, I think if there was strong feelings that we should put plastic policies into effect, we would have already started making more efficient decisions with plastics. Like, for instance, we have made decisions on which plastic to use where on a vehicle so that it meets the requirements and is the least expensive, right? We could have consolidated many of these plastics. We have over 200 different plastic materials on a typical vehicle when you take into account the plastic resin itself, the short glass, long glass, mixtures of glass and talc, level of talc. It's unbelievable. And it's because we have made those decisions based on cost and just basic requirements. So if there was a policy where, here's the material packages that automotive suppliers can use, we actually might end up with lower cost because we're using a greater amount of certain plastics, right? And better quality for the consumer because we've upgraded a certain number of them accordingly as well. So I don't have a problem with that, but I don't see much progress as far as policy.
Yeah, Americans and companies in particular, they don't like to be legislated very much or constrained. That's just the way it is. But yeah, those are great ideas, Debbie.
So maybe we can, pun intended, close the loop here. Debbie, early in the part of the conversation, you talked about the need to close the loop when it comes to using materials. Help our listeners understand. Can you explain what that means?
Yes. So I'll give you one example that we worked with another company and then one within our own company. So in 2019, we started working with McDonald's Corporation. And you say, what is Ford doing with McDonald's? And the reason I had a contact there was this gentleman who was in sustainability at McDonald's happened to work at Ford previous in his career. So it was a lucky strike. And we had a conversation and he talked about how coffee chaff, which is the skin that comes off the bean when you roast coffee beans, was being burned or landfilled. And he had all these plantations. McDonald's sells billions of cups of coffee a year. And believe it or not, there are piles and piles of coffee chaff at all of their plantations. And so we agreed that I would take a look at his coffee chaff and we put it into polypropylene materials. We had a bunch of summer interns. They were having a great time. I was drinking my coffee while they were doing that. And it turned out that 17% coffee chaff was exceeding the properties of 40% talc in headlamp housings. So this is the back of the headlamp housing and 17%. So it's lower density than talc and we use less of it. And we exceeded properties, especially heat properties, which is essential for a headlamp that is closed and has a bulb inside, right? So the engineers at Ford are thrilled because now I've got a higher heat material. I'm saving money because McDonald's is saying, I'm going to donate this material to you guys. We don't have a use for it. It was free. And we generated a little supply chain to make this material. So closing the loop is between Ford and McDonald's here, very unlikely partners. And I'm sure there are thousands of these ideas that people could have where one man's trash is another man's treasure. And we should do that. But another example within our own industry is we went to an engine plant and we looked at the engine being assembled and every single hole in that engine was plugged with a plastic plug, different color. And it told the assembly workers what to attach to it, what hose to attach to it. But we ended up with bags of these plastic caps. And I said, what's happening with these caps? And they said, oh, they go to landfill. I'm like, landfill? Like they're just sitting in there and they pull them out and they're like brand new. And they said, well, we don't really have any way to separate them. We don't have any way to use them. So our team is looking for, can we robotically separate these? Can we consolidate the number of colors? Can we use them again, just as they are? Can we separate the colors and just use them on engines 3 times over? There will probably be challenges, but we're looking at it. So there's huge amounts of opportunity. We recently just announced 3D printing waste, and every 3D printing process, if you ever used a printer, generates a lot of waste using 3D printing powder in actual car parts. So we take the waste powder, pelletize it, and injection mold it into fuel line clips. Again, all you got to do is look around for the waste, and it is not bad material. It's great material. And in that case, it was a superior material to the one we were currently using, a better nylon. So that's closing the loop.
That's awesome, Debbie.
And Paul, how about you when you're dealing with this with students? What does closing the loop mean to them and to you in your teaching?
I think a lot of what Debbie is saying, in fact, Debbie, I'd love to have you come and do a guest lecture in one of our material science classes.
I'd love it.
That was really inspiring. One thing that we could really leverage is the intelligence of the product itself to either request to be returned for recycling or do it itself in the case of a vehicle that can drive itself. So to me, that kind of leveraging of all this, hard work that the software engineers are doing to incorporate some of the recyclability aspect is an opportunity that we could really benefit from. And ultimately, I would think that, as you suggested, Debbie, you're saving money because you're reusing instead of rebuying. I hope, anyway. I know that in many cases it's just cheaper to make new material, but that's only because the science hasn't really been focused on using the old material as a starting point. And then if we start making new material with the intention of recycling and thinking about the larger system of making parts that are intended for recycling and then setting up plants and facilities where that can happen, it becomes seamless. It becomes a seamless closed loop when we're using less raw new material.
That's a beautiful, beautiful thought, and I totally agree with you. So you're going to get your guest lecture, but we just implemented a graphene filled plastic, and that was under hood, and we put less than 0.5% by weight graphene in, and we got like 30% improvement in noise, vibration, harshness, which is what you want on an engine cover and is what you want on pumps and pump covers, stuff like that. And so when you think about end of life, you say, oh, graphene's an expensive filler. I want that part back. And so I want our engineers to be thinking more along those lines of using premium materials instead of just thinking of plastics as junk. Let's use premium materials and let's plan to get them back and use them again.
And that's awesome. And with that, great conversation. Thank you both for being on here. Really insightful thoughts on how we could protect the planet, live more sustainably, save consumers money, still be safe, leverage technology for the future. What a great time to be part of the automotive industry. I want to thank you both for joining. You guys are great pioneers in this area. And I'm also happy you guys had an opportunity to connect. And I love to, if we're still in a virtual environment, I would like the Zoom link for that guest lecture so that we can, I can tune in and learn a few new things. So with that, Dr. Debbie, Paul, thank you so much for your time. Thank you for your insights. And we look forward to sustainably speaking to you soon. Thank you for listening to this episode of Sustainably Speaking, and special thanks to our guest. If you have any thoughts on today's episode, consider sharing it with your friends and colleagues, or including it in a rating and review. You can also reach out to us directly at sustainablyspeaking@americasplasticmakers.org. We'll be back in your podcast feeds on July 5th with a spotlight on sustainability and leadership featuring Eastman CEO Mark Costa. Together, we can change our perspectives, our behavior, and the world. I look forward to Sustainably Speaking again soon.